Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 4, which is the Mechanics for October-November 2023, and the code is 9709/43. So let's move on to question number 1. Okay, for question number 1, a particle is projected vertically upwards from horizontal ground with speed of u meter per second. The particle has height s meters above the ground at times 3 seconds and 4 seconds after the projection. Find the value of u and the values of s. Okay, so when I show this on a diagram, say this is the particle and this is the initial speed u at t equals to 3. Okay, and t equals to 4, it will be reaching the height of s meters. Okay, that means the particles reaches at s meters at t equals to 3 and t equals to 4. On other words, I know that it will continue until a certain level, then only going down. Alright, so now here, to get the u and s, okay, you need to count the u and s. I will just use the formula s equals to ut plus half at squared. So when t equals to 3, the distance is s, and then the u remains. I replace the t by 3 plus half a is minus 10, okay, because it was projected upwards. So then the t is 3, then you square it. So from here, I will be getting s equals to 3u minus 45 as the first equation. So now we consider when t equals to 4. So when t equals to 4, s equals to u times 4 plus half times minus 10 times 4 squared. Okay, then you will be getting s equals to 4u minus 80. That is our second equation. So from here it's mentioned that at these two t values, it will be having the same distance from the ground. Alright, therefore, now we just need to solve these two simultaneous equations. I will let second equation minus first equation. So for the left hand side, s minus s will be 0. Then here, 4u minus 3u, you will be getting 1u. Okay, just u. Then the next term is minus 80 minus 45. You will be getting minus 35. Then from here, we can easily get the u equals to 35 meter per second. Right, this is your u. So once you have found the u, to get the s, just substitute into the first or second equation. Okay, first or second. So from here, I will just substitute into the first equation. So now my s will be 3 times 35 because my u is 35. Then minus 45. And at last, you will be getting 60. So your s is basically 60. Okay, so we have two methods to solve this question. Another method is considering, okay, this motion here. Alright, so from here, or probably not this motion, is like the motion from original, okay, the initial time until the highest height. Okay, so because we know that when the particle reaches highest height, before it goes down, the v here is basically 0. Alright, and then the maximum height happens when it is 3.5 seconds. Alright, because when t equals to 3, it will be at the s meters. T equals to 4 also at s meters. That means when you consider go up and go down to the same level here, it just need 1 second. Okay, so if within 1 second, then you just consider half of the motion. Therefore, the t is 3.5. Okay, so here I show you second method to solve this problem. So you will be using v equals to u plus at. Okay, V equals to 0 at t equals to 3.5 seconds. Then from here, you can easily get your U. Then from here, I will get V equals to U plus A is minus 10, then the t is 3.5. So therefore, your U is going to be 3.5 times 10, which is 35 meter per second. So this is why you get it. Okay, then for the S, you can just use S equals to ut plus half at squared. So you'll be getting first or second equations, then from there you can get the S. So this is the alternative method to get the U. Okay? Now, next question is question 2. So question 2, a machine for driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of the nail. The mass of the hammerhead is 1.2 kilograms and the mass of the nail is 0.004 kilograms. Now, the hammerhead hits the nail with speed v meter per second. Right, here is v. And remains in contact with the nail after the impact. Now, the combined hammerhead and nail move immediately after the impact with speed of 40 meter per second. That means initially the nail is 0 here. Okay, this is the U2, for example. Okay, this is V. So after it sticks together, right, it sticks together for both, then it moves with 40 meter per second. Okay, so when you combine both. Alright, so now A calculates V, giving your answer as an exact fraction. So the V here is basically the speed, the initial speed of the hammerhead. Okay, so for this case, we need to use the linear momentum. So I will write m1 u1 plus m2 u2 equals to m1 plus m2 because they're combined together. You see, they're combined together. So m1 plus m2 times v. Okay, so the m1 is basically 1.2. That is your m1. So 1.2. The u1 is the v in this question. Then plus m2 is basically 0.004. Then the u2 is 0. Okay, so the total of the mass, it will be 1.2 plus 0.004, and then the v, the speed after they combine, it will be 40. Okay, then from here, for the left hand side, you will be getting 1.2 v. Then the right hand side, here you will be getting 1204 over 25. So when you calculate, so then your V is 1204 over 25 times 1 over 1.2. Okay, then you can just leave your answer in fraction because the question asks for a fraction. Right, so if fraction, I better change the 1.2 into 6 over 5 then. Here 6 over 5. Then this is going to be 5 over 6. Alright, then you will be getting 602 over 15. So that is your speed, which is the V. Okay, now part B. The nail is driven 4 cm into the wood. Find the constant force resisting the motion. Okay, let's say this is the hammerhead. Here is 1.2 G. Okay, and this is the nail. This is 0.004 G. Alright, so probably I draw like this. This is the mass. Then now when the hammerhead, okay, when the hammerhead, let's say the hammerhead is this. This is the hammerhead. Okay, this is 1.2 G. Now you need to calculate the force, the constant force resisting the motion. That means you should have the R over here. Okay, basically you need to find what is the R. Okay, and then we know that the hammerhead is basically moving down, but then we do not know what is the A. Okay, so now before you get the R, we need to get the A first. Alright, so for the A, I need to make use of this 4 centimeters. That is the S. So given S equals to 4 centimeters, okay, but remember your speed, the unit is meter per second. That means now instead of centimeter, I need to change to meters. So here is basically 4 times 10 power negative 2 meters, or probably you can just write 0.04 meters, because 1 meter equals to 100 centimeters. Okay, so now I will use v squared equals to u squared plus 2as to get this a first. And now given the v squared, okay, so when it combine, when it is the nail is driven 4 centimeters into the wood, that means the v is 0. Okay, because it's already in the wood, so the nail will not be moving anymore. But then this u squared is the speed after the combine, which means it is 40. Okay, so this is going to be 40 squared plus 2a, the s is 0.04. Then from here I will be getting 0.08 a equals to negative 1600, because you move this 40 squared to the other side. Then from here your a is going to be negative 1600 over 0.08, and then you will be getting negative 20,000 meter per second squared. Alright, so with this A, now to get the R, which is your actual question, I will just use F equals to ma, the Newton's second law. So now, when you look at this diagram right now, okay, so your F downwards forces, it will be 2, which is 1.2 G and 0.004 G. Okay, but then here we have the R. R is in the opposite direction of the green and blue forces. Therefore, you minus R, because there is a resistant force. Then it will be MA. So now for the M, it will be both of the combined object. So it will be 1.2 plus 0.004, then times by the A. So the A is negative 20,000. Okay, then from here to get the R, very simple. Since this is minus R, just move it to the right side and move all these terms to the left side. Okay, so then from here I will be getting R equals to 1.2, G is replaced by 10, then plus 0.004, G also 10. Since here, look at here, this, when you do expansion, it will be a negative value. So this negative, you move to the other side, becomes plus. Right, so I will just write plus, then 1.2 plus with 0.004 means that this is 1.204 multiplied with 20,000. Okay, then from here, at last, when you get the total, it will be 2409 2.04. Okay, so now we always round up our answer close to 3 significant figures. Therefore, it will be 24100 newtons. This will be the requested force. Okay, now next question number 3. A block of mass 8 kg, 8 kilograms, slides down a rough plane inclined at 30 degrees to the horizontal. Starting from rest, the coefficient of friction between the block and the plane is mu. The block accelerates uniformly down the plane at 2.4 meter per second squared. Now A, draw a diagram showing the forces acting on the block. Okay, basically, this is the plane. So this is the block. Now the question asking for forces. Firstly, you must have the weight, which is hg. Okay, because the mass is 8. Then it is inclined 30 degrees. So now, and you have a frictional force. Okay, so it's mentioned that it will be sliding down. So that means your motion is sliding down. So the frictional force is upwards. So F(r) equals to mu r, whereby my R is the normal reaction. Okay, so this is the diagram that's showing the forces. Alright, done for the first part. Now B, find the value of mu. Okay, so for value of mu, I know that this block is going to be moving down, and then the u is 0. Okay, because starting from rest, and then accelerates uniformly down the plane at 2.4 meter per second, means that the A is 2.4 meter per second squared. Alright, so from here, to find the mu, what I need to do is I need to get the R first. Right, my R, basically, if you refer to this plane, okay, then here is 30 degrees, that means this angle is also 30 degrees. Alright, so okay, or probably I will just add on all this on the I will do it separately because this is the solution for the part A. So now I will just redraw this. Okay, so basically your diagram is like this, 30 degrees. Here is hg. This is the R. Okay, here is Fr equals to mu r. Now u equals to 0. So u equals to 0, A equals to 2.4. Okay, so from here I will write my R. So then from here I know that this is going to be 30 degrees because given angle is 30 degrees. So then my R, basically it is to get, you can obtain it by resolving this hg vertically, perpendicularly to the plane. Therefore, since you are using the angle, the given angle, we are using cos. So R is basically hg cos 30 degrees. Okay, so it will be 8, g is 10, cos 30 degrees is square root 3 over 2. So at last, I will be getting 40 square root 3. So that is my solution for the R. Okay, so after this, to get a mu, I know that this particle is moving down. So therefore, I will be using Newton's second law. So it will be hg. So now going down, that means now I have to resolve parallelly to the plane. So when I resolve the hg, it will be called sine 30 degrees because this angle is not given. I'm using the alternate angle. Therefore, I will be getting hg sine 30 degrees. Then I minus the Fr. Fr is mu r. Okay, mu r. R is 40 square root 3. Then equals to ma. M is 8. The A is 2.4. So then now, to get the mu, this whole mu term, you will move it to the other side, and the 8 times 2.4 will be moved to the left side or right side. So here I will write 40 square root 3 mu. Okay, then it will be 8g. G is replaced by 10. Then sine 30 is half. After that, the 8 times 2.4 will be moved to the other side, becomes negative. Then from here, when you calculate the right side, it will be 20.8. Okay, hence your mu is going to be 20.8 over 40 square root 3. So at last, you will be getting 0.3002. And now I round up to 3 significant figures, that is 0.300. So that is your mu value. Okay, now next, part C. Find the speed of the block after it has moved 3 meters down the plane. Okay, so from here, I will say v squared equals to u squared plus 2as, because the speed, the final speed you do not know, the s is given, then the u is given here. The u is basically 0. Okay, so now I will just write this is 0 squared plus 2a. My a is 2.4 is given in the question. So then 2.4 and then the s is 3. Okay, then from here you will be getting 14.4, but this is for v squared. So our v is square root of 14.4 and you will be getting 3.79 meter per second. So that's the solution for part C. Okay, now next question number 4. A car has mass 1,600 kilograms. A, the car is moving along a straight horizontal route with a constant speed of 2.4 meter per second and is subject to a constant resistance of magnitude 480 newtons. Find in kilowatt the rate at which the engine of the car is working. Okay, so now from here, the rate at which the engine of the car is working is basically referring to the power. Okay, you need to find what is the power. So we know that power equals to F times V. But before that, I have to find out what is your driving force. Okay, let's say this is the car. So the M is 1,600 kilograms. Okay, this is the driving force, D. And then there is a resistance, 240 newtons. Alright, constant speed means that the A equals to 0. Alright, then from here I will just use F equals to MA to get the D first before I get the power. So this is basically the power. So the power is D times V, the driving force times V. So now I know that the car is moving to the right side, therefore D minus 240, because 240 is a resistance force which is against the motion. Then equals to M is 1,600, the A is 0. Okay, so obviously your D is 240 newtons. And then now I will just write power equals to D times V. So now my D is 240 and then my V is 24. Okay, so then from here you will be getting 11520 watt. But then it's mentioned kilowatts. So now you just move the decimal three places for backwards. That will be 11.52 kilowatts, and now round up to 3 significant figures, it becomes 11.5 kilowatt. So that is the solution for first part. Okay, now the car now moves down a hill inclined at an angle of theta to the horizontal, where sine theta is 0.09. Okay, let's say for example, this is your diagram. This is theta. Okay, this is the car moving down. And remember, it has 1,600 weight. The weight is 1,600 G. Okay, so now sine theta is 0.09. Now, the car of the engine is working at a constant rate of 12 kilowatts. That means the power, okay, power is 12 kilowatts. Okay, then from here I will say that you can find the work done later on, because from the power you can find work done. Okay, so now the speed of the car is 24 meters per second, so U equals to 24. At the top of the hill, 10 seconds later, the car has traveled 280 meters down the hill and has a speed of 32. So when it reaches here, That means the V equals to 32, and then the T is 10, then this distance is 280. Okay, now B, given that the resistance is not constant, use an energy method to calculate the total work done against the resistance during the 10 seconds. So now, according to the new energy method, right, that means you need to consider total work done. So now I will say that my work done by engine, it will be the power, okay, this is 12,000 watt times 10, because work done is work done is F times D. So your F is the power now. So then from here you will be getting this amount. Okay. Then now, according to the energy method, so total work done equals to increase in mechanical energy. Alright, so the total work done is basically the work done by engine, or the work done to speed up the body. So that means it's the 120,000 minus work done against resistance. Then the increase in ME, mechanical energy, is basically increase in KE, kinetic energy, plus increase in gravitational potential energy. Okay, so that means this is increase in KE plus increase in GPE, or you can just write PE. Okay, so from here I will say my work done against resistance. So I will just move this to the right side and move these two terms to the left side. Okay, so here it becomes 120,000 minus increase in ME is basically the final ME minus initial ME. Okay, this is final ME, final kinetic energy, final KE, minus initial KE. Okay, same goes to the increase in PE. So it will be final PE minus initial PE. Right, so from here I will just say final KE is basically half mv squared. That is the final KE. So half mv squared. This is gravitational potential energy is mgh. Right, so now half m is 1600. V squared, the V is 32. Okay, then now because I need to minus initial KE, so now the difference between the initial KE and the final KE, kinetic energy, is just the V. So here I minus the initial speed, which is the 24. Okay, otherwise you can just split it into two terms like this. So it will be half mv squared, 32 squared, minus half mu squared. Okay, then you plus with mgh. So initially it is here, so I will assume it is at the h of 0. Okay, so it will be 0, then minus initial PE. So at first the height, it is here. Right, so I need to know what is my height over here. That means I need to resolve this 280 meters vertically. So I resolve vertically. So this angle is not given. This angle is not given. I'm going to use the theta. Therefore, this will be sine. Okay. So when you resolve the 280 here, this length vertically, you are getting this as h. Right? So then this is your h. Okay, then I will be getting m is 1600, g is 10, then the h is 280 sine theta. Okay, because it's like triangle, here is your theta. Alright, so then you remember to close the bracket. Then from here, I will be getting 120,000 minus, right? So here you can just rewrite, or otherwise you can just calculate how much is that. Then I will just rewrite first. I didn't calculate. So basically from here you will have the common term. See, all these are common terms. So I can just direct take up and combine the common terms. So this is going to be 32 squared minus 24 squared, then minus 1600 times the 10, so 0. So you get 280. Sine theta is given, which is 0.09. Okay, so when you minus all of this, then at last you will be getting 164800 joule. So this is the actual value. Okay, so if you want, you can just leave it in this form or round up to 3 significant figures, then you will get 165000. That will be 3 significant figures. Okay, now next question, number 5. A light string AB is fixed at A and has a particle of weight 80 newtons attached as B. A horizontal force of magnitude P newtons is applied at B such that the string makes an angle theta degrees to the vertical. Now it's given that P equals to 32. So this is 32 newtons. And the system is in equilibrium. Equilibrium means that the system is not moving. Right? I mean the particle is not moving. So now find the tension in the string and the theta value. Okay, so what I need to do here is I will label this is the tension of the string, and then here, right, let me label this is a T. So now this is going to be theta angle. So now what to do is you need to resolve all the forces vertically and horizontally. So when I resolve the force vertically, the tension vertically, I'm using the angle theta. That means this is going to be cos. Okay, so this upper force is balanced by the downwards force. Right, the upward force is balanced by downwards force. Therefore, T cos theta is 80. So this is my first equation. And when I resolve horizontally, that means now this T will be resolved down. So this angle is not given the orange color, okay? That means I'm going to use the theta over here. Therefore, that is sine, right? Because I'm using alternate angle. Then you will be getting T sine theta equals to 32, which is balanced by the P. So this is my second equation. Now to solve these two equations, I will use second equation divided by first equation. So for the left hand side, the T will be cancelled off when you divide. Then I will just get sine theta over cos theta, which is the tangent theta. Then it will be 32 over 80. Okay, then from here, your tangent theta is, because the questions ask for theta value. Okay, so from here, your tangent theta is 32 over 80 means it is 4 over 10. Oh, let me count. Sorry, it is 2 over 5. Okay, then your theta is going to be inverse tangent 2 over 5, which is 21.8 degrees. So that is your theta value. Now after you have found the theta, then you can just substitute into the first or second equation to get the t. So now here I'm using the first equation. So from first equation, t cos 21.8 degrees equals to 80. Okay, that means your t is going to be 80 divided by cos 21.8 degrees. Then this is going to be 86.2 newtons. So that's the solution for part A. Now B, it is given instead that the tension in the string is 120 newtons and the particle attached at B still has weight 80 newtons. Now find the P and the theta. So what we need to do here is I will just redraw this diagram. Okay, so it looks like this. Here is 80 newtons, and then now your T is 120. This is theta, okay, which means here is also theta. Right, now use by the same formula or same method, resolve vertically. So I will get T cos theta equals to 80. Okay, so now your T is 120. That means 120 cos theta is 80. Therefore, I can get the theta. So cos theta is 80 over 120. It is same as 2 over 3. Then at last, your theta is inverse cos 2 over 3. And you will be getting 48.1897. And now I round up to one decimal place. That is 48.2. Okay, now to get the P, so we resolve horizontally. So when I resolve horizontally, it will be 120 sine theta. Okay, so I will write T sine theta is P. Therefore, my T is 120, then sine 48.2 degrees. So now for the calculation, better don't use the rounded off value. We use the actual value. So write 48.1897 degrees. And now from here, you will just get 89.4427. And I will round up to 3 significant figures. That will be 89.4. So your P is with this amount. So done for the parts B. Okay, now next question number 6. A particle moves in a straight line at time t seconds. The acceleration a of the particle is given by a equals to 36 minus 60. The velocity of the particle is 27 meter per second when t equals to 2. So find the values of t, so values more than 1t here, when the particle is at instantaneous rest. That means this is v equals to 0. So you need to find the t when v equals to 0. Okay, and given the a. So now a equals to 36 minus 60. My our v is integrate a dt. Okay, therefore now you integrate 36 minus 60 with respect to t. And now for the integration, you just add 1 degree of t. So it will be 30/60 for the first term, and minus 60 becomes 6t squared over 2. Don't forget the plus c, and now your v is basically 30/60 minus 3t squared plus c. So to get the c, use this value, t equals to 2, v equals to 27. That means now I will be getting 36 times 36 times 2. minus 3 times 2 squared plus c equals to 27. Okay, then from here, your c, you can just move the terms, all these terms to the right side. So it will be 27 minus 36 times 2, and then plus 3 times 2 squared. So at last, you will be getting negative 33. Okay, so now you rewrite your v is 36t minus 3t squared minus 33. And now, the question asking for when v is 0, what are your 2t? Okay, so when v equals to 0, that means 36t minus 3t squared minus 33 equals to 0. So from here, I can rearrange the equation. It will be negative 3t squared plus 36t minus 33 equals to 0. And now here I notice that in order to get the positive t squared, I have to divide the whole equation by minus 3. So at last, you will be getting t squared minus 12t plus 11 equals to 0. And now factorize this quadratic equation to get t minus 11 and t minus 1. Okay, therefore, I will get either t minus 11 equals to 0 or t minus 1 equals to 0, which means here I'm getting either t equals to 11 or t equals to 1. So that's the solution of this question. Okay, now part B. Find the total distance the particle travels during the 12 seconds. So now I need to calculate my distance. But then before that, let's look at the v first. Okay, we know that distance is the integration of v. So now I need to sketch this graph. Okay, so v equals to minus 3t squared plus 36t minus 33. And just now we know that when t equals to 1 and 11, the v equals to 0. Okay, and this is a quadratic curve. So then I simply sketch. So then I know that when t equals to 0, my v is going to be negative 33, because when you replace a t by 0 here, obviously it's negative. So just simply sketch. Okay, let's say this is your graph. We just need to get the idea how's the graph. This is negative 33, and then here is going to be 1. This is a v, this is a t. Okay, and here is 11. Now, let's say you calculate what is the v when t equals to 12. Okay, so if not, you can just simply sketch. Now let's say this is 12. Okay, so what to do here is, we know that your distance, right, s equals to integrate v dt. But then when you refer to the graph, okay, the region from 0 to 1 is basically here, below the x-axis. 11 to 12 is also below the x-axis. That means for your integration, you have to put modulus. Okay, but then for 11 to for t equals to 11 to for t equals to 1 until 11, the region is above the x-axis, so no need to put modulus for your integration. That means here I will just write for 0 to 1. Okay, I have to put a modulus. So here is going to be negative 3t squared plus 36t minus 33 dt. Okay, plus integration from 1 to 11, which is the middle part, just normal integration. Okay, then plus modulus of integration from 11 to 12, negative 3t squared plus 36t minus 33 dt. Okay, so now For this integration, I will just write s equals to modulus of, when you integrate the first term, is basically minus 3t cubed over 3. Then the second term is 36t squared over 2. Then last term, 33t. Now with limits 0 to 1. That's your first integration. Second integration will be the same, just copy. So just change the limits accordingly. Okay, same goes to the third integration. Just copy all the terms. Right, so now my working is, you see the first one is basically minus t cubed, right? So I will just write it is minus t cubed plus, then the second one is 18t squared. So I will just rewrite all of this, all of the rest. Okay, then now you just replace the limits. So the first one is 1. So minus 1 cubed is minus 1. Okay, then plus, when you replace the t by 1, it will be 18 for the second term and minus 33 for the term. And when you replace the t by 0, everything is 0. Okay, now for the next one, you replace the t by 11. So negative 11 cubed. Okay, then plus 18 times 11 squared minus 33 times 11. Then all of this, you have to minus the value when the t is 1. So when the t is 1, basically you just copy the rest, the previous values. That means minus 1 plus 18 minus 33. Okay, so now, lastly, replace the t by 12 first. So I will get negative 12 cubed plus 18 times 12 squared minus 33 times 12. Then you minus whatever value that you have solved in the previous part. That means all this. Okay, because all these are the values when t equals to 11. So I will just copy all this. Right, so when you calculate, the first one is basically modulus of negative 16. Then the next term will be 484 minus negative 16 that you get from previous part, plus the last term, it will be modulus of 468 minus 484. Okay, with the modulus. Then here I will be getting, this is 16. Second term you will get 500. Then last term, after the modulus, it is basically positive 16. So at last, total up of all these three values, you will be getting 532 meters. So this is the total distance. Okay, now question number 7. So particles A and B of masses 2.4 kilograms and 3.3 kilograms respectively are connected by a light inextensible string that passes over a smooth pulley which is fixed to the top of the rough plane. Okay, now the plane makes an angle of theta degrees with horizontal ground. This is a theta degrees. Particle A is on the plane and the section of the string between A and the pulley is parallel to the line of greatest slope of the plane. Particle B hangs vertically below the pulley and is 1 meter above the ground. Here is 1 meter. Now the coefficient of friction between the plane and A is mu. Okay, now given that theta is 30 degrees, theta is 30, that means this is 30 degrees, and the system is in equilibrium, means that it's not moving yet, with A on the point of moving directly up to the plane. That means this is on the point of moving up. So when moving up, this is your A. Okay, then the frictional force, because you are given the coefficient of friction between the plane and the A is mu. Therefore, frictional force is going down. So this is your Fr equals to mu R. Right, now show that the mu is 1.01, correct to three significant figures. So what I need to do here is, okay, since the A is in contact with the plane, right, I should have the weight. So I need to consider the weight. This is 30. So here is 30 degrees. Then this is the weight of 2.4 G. And the reaction force, which the normal reaction, which is the R. Okay, and now from here, I need to resolve first. I will label the tension of the string as T. Then here is also T. Now, the B is expected to go down, and then the A is going up. Okay, so when I resolve, I consider the B first, according to the Newton's second law, F equals to ma. So at the particle B, right? So this is A. So then for the B, you will have the weight of 3.3 G. So obviously 3.3 G minus T equals to ma. So 3.3 G minus T equals to 3.30, because at this moment it is still in equilibrium. So there's no motion yet. Your A will be 0. Okay, because no motion. The V is 0, definitely the A is 0. Right. Then from here, I can find my T directly. So which means my T is basically 3.3 G. My G is 10. Then you are getting 33 newtons. Okay, so now at the A, look at the A now. So the A, you have T, you have the mu R, and you have the weight. So I will say for the A, since it's moving up, so then the upwards force, it will be the T. But then for downwards force, it will be the, you have to resolve the mass, the weight, which is a 2.4 G, together with the Fr. Okay, so now I need to get my R first. So basically, at A, my R is basically, you resolve. Okay, this is my, you resolve the R to here. This angle is theta, because you are given theta over here, which is 30 degrees. So I will say this angle is 30 degrees. Okay, so now you resolve. This is 2.4. So you resolve the weight so that it is perpendicular to the plane. I will get 2.4 G cos 30 degrees. That is my R. Alright. Then from here, I will just consider the Newton's second law. So T minus, now for the T, okay, so now I have to resolve this mass, this weight, so that it is parallel to the plane. So when I resolve over here, that is cos, that is sine 30 degrees, okay, because your angle is not given, this angle. So that's why I'm using the alternate angle. So it will be T minus 2.4 G sine 30 degrees. Then at the same time, I have to minus the Fr. So my Fr is mu R. So minus mu R is 2.4 G cos 30 degrees. And it is same as 2.4 times 0. Okay. Then from here, to get the mu, right, the question asks for mu. So what I need to do is, this whole mu, I will move to the other side because of negative. Then this right side already 0. So I will just need to calculate the left hand side here. Okay, so now I will get mu times 2.4 times 10 cos 30 degrees equals to, my t is 33, minus 2.4 times g times sine 30 degrees. So from here, you will get 12 square root 3 mu equals to 33 minus 12. So then you will get 21 on the right side. Therefore, your mu is 21 divided by 12 square root 3. Then this is 1.0104, and now you round up, it will be 1.01. So this is how we show the mu value. Alright. Now, next part is given that instead theta is 20 and mu is 1.01. The system is released from rest with the string taut. Find the total distance traveled by A before coming to instantaneous rest. You may assume that A does not reach the pulley and that B remains at rest after it hits the ground. Okay, so now what's the difference now here is you can just change this to A because it is moving down right now. Okay, and then to get the A first. Okay, so the rest remain. Just change the A to the no more 0 for the A. Right. So I will rewrite all the calculations and change the theta to 20, no more 30. So now I will write F equals to MA. Okay, so at the particle B, refer back to previous calculation or previous equation, you will be getting this. Then from here, my T is basically 3.3, G is 10 because I need to get my expression for the T. So means my T moved to the other side and then my A moved to the other side as well. Okay, so opposite sides. That means now it will be negative 3 minus 3.3A. Then I will get my T as 33 minus 3.3A. That is my first equation from the particle B. Now my particle A, I will just copy everything. Okay, copy this whole equation by changing this 0 to A and change the 30 degrees to 20 degrees. Okay, the rest remain. And replace the mu value by 1.01. So I will get T minus 2.4G sine 20 degrees then minus 1.01 2.4G cos 20 degrees that equals to 2.4A. Okay, I let this be second equation. Now I substitute T from the first equation into second equation. So first substitute first into second. So I will be getting 33 minus 3.3A, then minus 2.4, my G is 10, then sine 20 degrees, minus 1.01 times 2.4, the G is replaced by 10, then cos 20 degrees, okay, that equals to 2.4A. Now, from here, you have this minus 3.3A and 2.4A. So this minus 3.3A will be moved to one side. Okay, so I will write the A first. So it means you will be getting 2.4A plus 3.3A that equals to the rest of the terms. So the rest of the terms, if I calculate, okay, all these three terms, when I calculate, it will be 2.013367. So now 5.7a, it will be this value. That means your A is going to be 0.3532. So here I give more decimal places or more significant figures. Okay, now I know that my two particles are moving up with that values. And then it's mentioned that when the B hits the ground, okay, when the B hits the ground, so that means the B has traveled for 1 meters. I need to find out what is the V over here. What is the speed? And same at the same time, when the B goes down by 1 meters, the A already moves up for 1 meters. So I need to find the V. It will be the same V. Okay, before the A comes to rest. So now what I need to do here is I need to refer to the V squared equals to U squared plus 2AS. And I just consider my A or B, up to you. Okay, so now here it will be the U is 0 because initially 0 plus 2. My A is 0.3532. Then the S is 1 meter. Then now you will be getting is 0.7064. Okay, so the V is basically 0.8405. So this V is the V at when the B hits the ground. Okay, so I will say here V is the speed when B hits the ground. Right, so now, which means at this moment, okay, your V is here, your V is 0.8405. Okay, but the question says, right, you need to find how much is the distance traveled by A when it comes to rest. So when rest, here will be 0. Okay, this is a V2. So now I need to find how much is this distance. I know that here is 1 meters. Here is already 1 meter. Okay, how much is the S? So with the V, with the U, okay, this 0.8405 becomes the initial speed, and then the V2 equals to 0. This is the final speed. So from here, I can just use, okay, now wait, we have to find out what is the A first. Okay, what is the A? Because at this time, the string already slack, right? So then I have to find out what is my A. So when my A, what to do is you just refer back to this equation. Okay, where is the equation? To the Newton's law. I mean the Newton's second law equation, but ignoring the T because at this time no more tension. Okay, I need to recalculate my A. So I will refer back to this second equation by ignoring the T and recalculate the A. Okay, so I will rewrite. It will be negative 2.4 G sine 20 degrees. So here at A, negative 2.4 times 10. So you can just write here, when B hits the ground, T becomes 0. Okay, then here, sine 20 degrees. Then, okay, so refer to this. Minus 1.1 bracket 2.4 G cos 20 degrees. One 2.4 G cos 20 degrees. That equals to, lastly, right side 2.4A. Okay, then from here, 2.4A equals to negative 30.9866. So that's your calculation. Then now your A is going to be negative 12.911. Okay, so that means without the tension, now your A becomes, so here, A becomes negative 12.911. So to find the S with the V, with the U and A, I can just use V squared minus equals to U squared plus 2AS to get this S. right? So then you will be getting v squared equals to u squared plus 2as. So my v is 0 because it comes to rest. Then the u squared, okay, now your u is this, sorry, you refer to this, right, this value, but we know that, sorry, this is your u, initial speed, and then you can just take this directly, 0.7064 as the v squared, okay, the v squared here as your u squared over here, it will be the same. Therefore, I will just direct take 0.7064 plus 2, my a is just counted, negative 12.911, then the s is unknown. So from here, when you calculate this total, it will be, okay, at the same time, this is negative, so I can just move it to the other side. So after you have counted the value, you will be getting 25.822s. That equals to 0.7064. Okay, hence your s is going to be 0.7064 divided by 25.822, and this is going to be 0.02736. Okay, this is in meters. So then from here, I can find the total distance that traveled by the A, because I have found this S. So this S together with the 1, that is the total distance. Okay, so then you can just add with 1 to get the final answer. So total distance traveled by A equals to 1 plus 0.02736 meters. And now I will be getting 1.02736 meters, and now I round up to 3 significant figures, that will be 1.03 meters. Okay, so that's the solution of this question. Alright, so we have completed the whole paper and also comes to the end of the video. Thanks for watching. Okay, if you enjoy watching my video, you can just share it with your friends and also buy the super thanks to support this channel. Alright, stay tuned for more upcoming videos. Thank you. Bye.